if you really program C++ today, the modern version, then C++ can be incredibly safe. So I think we have to do a much better job in teaching how to use the language. That is difficult.
But why does the C++ community at large hate pointers? Why are they so bad? Welcome to The Curious Developer. I'm Jesper Pedersen from KDAB, and today I have the pleasure with me here to talk to Klaus Iglberger, the well-known, best-selling author, I'm sure, of C++ software design patterns. As you can see, I made it into the first 1/10 of the book, but I'm sure he can answer a lot of my questions in this interview. Klaus is touring around with the C++ Roadshow, it at least feels like that, giving a presentation that is, and let me just read up here, it says, the real problem is not C++. And he has a point in there that says that the problem is a people problem, which brings me to my very, very first question. Klaus, do you bring a bodyguard to conferences these days?
Not really. So the title is The Real Problem of C++, not is C++. That would be a little negative. Then I need a bodyguard.
Can you tell me a bit behind the idea of this title?
So from my point of view, the safety discussion is a little too focused on the dangerous parts of C++. So in this talk, I want to focus on the positive aspects, because if you really program C++ today, the modern version, then C++ can be incredibly safe. And so from my point of view, it's not a language problem only. It's pretty much a mindset problem. People do need the right mindsets to just use C++ as it's supposed to be used. So to give an example, already in the first C++ standard, we've introduced these algorithms. In 1994, essentially, even before the standards they were introduced. If you would use algorithms instead of writing your own loops, then I would say already more than 90% of all out-of-bounds access violations would just disappear. And the code would be cleaner, the code would be simpler and much more maintainable too. And so that is definitely something that we should do. And still, many people do not. I believe this is because people are not aware, people don't want to. There's still this idea of, I should do it myself, I can write better code. And that, I believe, is the real problem of C++.
But isn't it also a matter of that C++ is not exactly a new language? I mean, if you were developing one of those really just new languages, your Stack Overflow, as if that was anymore, but your AI assistant would just give you suggestions as the right way. I mean, my AI will still suggest code that looked pretty awesome in before Jesus was born.
Yeah, indeed. But AI tools are fed with the code that they've seen, for instance, on Stack Overflow. And it kind of proves the point. Too many people write the raw loops instead of using the algorithms.
Well, both your AI and Stack Overflow, but also your own 10 million line code base, it looks like it does. And you learn from what all your coworkers did. And I mean, there is a balance here too, isn't there? I mean, if you walk into a new code base and it's like, guys, hey, I'm the new guy here. I want to do it the right way. So I will introduce type erasure. I will introduce all of these modern techniques all over the code base. Then elderly gentlemen, none mentioned, will feel that, hey, they don't even understand the code anymore. I mean, is that a problem? Isn't there an issue there? How do you cope with that?
So I personally cannot cope with that. This is what the community needs to cope with. That's also something I mentioned in the talk explicitly. Our teaching material is not really up to date anymore. So I bring an example of a book that is, I would say, famous. Yeah, it's already in the 6th edition, and it teaches C++ from beginning to the more advanced stuff. Yeah, kind of a complete book. But already in chapter 7 out of 35, I believe, there's a sentence, something like, sometimes writing code in C++ is like driving without lights at night. So this is in chapter 7 or pretty much in the first third of the book already. But this is the attitude towards how C++ is. And of course, I totally understand that people feel it's unsafe and it's not up to the challenges that we have today. So I think we have to do a much better job in teaching how to use the language. That is difficult.
But at least there are people like Gans talks about out there I interviewed him 3-4 months ago, and he was pulling up, well, at least the virtual, the one that we had to put into his hand afterwards in post-production book, and saying, hey, in my book, we make it to chapter, I can't remember, 17, 18 or something, before we introduce pointers.
Indeed, which is good. But now, since you mentioned Björn always, every year at CPPCon, gives a keynote talk. If you now go to YouTube, say to the 2024 talk, you see that, I actually checked this morning because of my talk, 178,000 people have watched the talk. That's an amazing number, isn't it?
It's pretty good.
It's pretty good.
More than where we'll be watching this.
Absolutely. A few more. But still, this is kind of the maximum that any talk in C++ would get. And it's a small fraction of all the C++ programs out there. I think that's a problem. There is a bubble. Now, we live in a bubble in C++. I call it the 10% bubble, and sometimes even exaggerate, say it's the 1% bubble. 1 to 10% of developers actually care about upgrading their knowledge, really writing good code. Rest apparently does not. Yeah. And so perhaps you could now indeed again say, but then it's a language problem. Even those people should write good code automatically, or they should be forced to do that.
Why am I here even? Can I walk out now? He's taking all my questions from me.
My point is, if you would do a better job at teaching this from the very beginning, tell people, please do not write all of your for loops yourself, use the algorithms, and so many of the problems would go away.
So we need an event really where everybody can come with their 20-year-old C++ book and burn it. So we can upgrade to the newer books like Bjarne's that are focusing on the more modern way of doing it.
There's also 2 books. So one book is out already from Frances Buontempo. She's currently writing a beginner book also.
Yeah.
And I encouraged her to write a book for beginners because from my point of view, she has the right idea of how to use C++ and how to teach this. Yeah, the safe part, the simple part, and not the dangerous things first.
I have many roles in my company. Among all of these things, I'm also the HR director. And one of the things that I'm telling people a lot is you need to continue educating yourself.
Absolutely.
I'm curious to hear from you. What percentages of time should people spend on learning modern C++, for example?
Difficult question because it always depends a little bit on the person. There's some people that just automatically learn new stuff. People that go to YouTube, watch the news videos, the conference recordings, people that actually read books. So there is a small portion of people that just do this automatically and don't really care how much time they put in. But I would argue, pretty similarly to what Robert Martin said in one of his books, I think it was The Clean Coder.
Mm-hmm.
So if you have a usual day job, then 8 hours every day kind of belong to your employer. But you should spend 1 extra hour to kind of upgrade yourself. Yeah, this is something that you should do with yourself. So say 1 hour a day is, from a point of view, a pretty good proportion of the time spent in improving. Reading books is one thing. Watching talks is a good thing. Blogs are the third thing. And there's even a podcast in C++, which brings you up to the greatest and latest news of the community. Just do something. So I usually recommend the podcasts for when you commute.
I work from home.
Oh, okay. Then you have the disadvantage here.
So I'm listening to that every day I commute.
But if people do commute, they may have 30 minutes extra anyway. Why not listen to the podcast and bring yourself up to speed? Reading would also be possible if you sit on a train or bus, whatever. That would not work so well if you drive cars, for instance. But
yeah.
And why not watch a video every other day? Now there's so good recordings, so amazing topics. It is a shame that so few people actually watch them.
I travel quite a bit, and I actually bought myself a tablet for watching videos when I'm sitting in the airplane and we're ready to take off, and they stole my laptop, and I'm just sitting there And I tried so many times to bring a book, and you had no idea. Here's one of them. Did I mention his book? Did I mention how far I made it in? All of that was read on an airplane, like, So watching, but you need actually a tablet for that, I find, because sitting there with your small phones, like code example.
Indeed, that's a problem. You actually said best-selling author. I think I've sold approximately 2,500 copies of this book.
Oh, that's a pity.
It's actually good. It's a book that sells pretty well. Yeah. But it again shows how few people actually invest in books.
Yeah. Well, between you and I wrote a book on Emacs 25 years ago. Sold so bad that the author offered me to buy a pallet of my book full price. Like, I don't think I need a pallet of my own book, but thanks anyway. So Martin Fowler, the refactoring book, he got a kit when he wrote that. At least he wrote in his intro, that's why he's talking about code stinks. If there's anybody out there, we already touched on the for loop, and overflow is solved by that. But why does the C++ community at large hate pointers? Why are they so bad?
So pointers are notoriously difficult to use correctly. So pointers can be null pointers, dangling pointers, uninitialized pointers. There's so many things that can go wrong with pointers that just the number of bugs with pointers is extraordinarily high. And it's just statistics. Yeah, many of the bugs, a high percentage, and of course I don't know the exact number, is because of pointers.
92.83. I looked it up this morning.
Okay, perfect. So as I said, extraordinarily high. So we don't hate pointers. We definitely realize that they're needed. Pointers are important. And even the languages that pretend that they don't have pointers do have pointers under the hood. But we do not like to use them in the open anymore because of the many problems we have with them. Therefore, we try to encapsulate them, try to hide them in some way, put them into classes, put them into some things that pretend to be simple to be used. And then as soon as they're encapsulated, as soon as they're gone, I don't really have to think about them anymore. I think that's what we do. It's not that we hate them, but we perhaps are a little afraid of them. Perhaps that's it.
So I'm afraid of spiders and you're afraid of pointers. There we are.
Indeed.
It brings me back to the original question. So you sit there with a code base. It's 10 million lines of code. And I come from a Qt background. And as Bjørn Strostrup said, Qt, that's a rat nest of pointers. And he is indeed right about that. I mean, we cannot allocate my label on the stack. So there's two questions in here. First of all, how do I, if I'm looking at my code base, how do I start transitioning my code base into something more modern?
There's actually multiple answers to that. So first, please never try to change everything at the entire code base at once in a short time frame. It just never works. It's totally unrealistic. Always just look at the things that are most crucial. So say you have these 10 million lines of code, but you're probably not changing these 10 million lines of code altogether. You probably just work in a small portion, say 10,000 lines of code, perhaps 50,000 lines of code. Then that's the critical part. If you now realize that something is difficult to understand, difficult to change, difficult to work with, then that's the first thing that you should touch and think about. Not the rest, not the 10 million lines, but just this little portion. And that's definitely much safer already. So it's kind of the hot code that you're working with right now. So you can do things manually, slowly upgrading, replacing for loops and obviously algorithms with calls to algorithms, encapsulating pointers more and more. But of course, that's a long time that you have to invest, a big effort. And so today I would actually recommend that you try out tools that assist you. And AI may be a great choice indeed.
Can you please rewrite my whole code base so Klaus will be happy with it? That's going to be good.
If that works, I would immediately buy the tool. AI is actually pretty good to see these patterns. And if something is used in a code base again and again, then it might be able to refactor this quite satisfactory. I would definitely try that. I don't say it's at the point where it's perfect and there's no problem. but it actually works surprisingly well. This is something that somebody also told me in the workshop I just did it at NDC Tech Town. A person came to me and asked me which AI tool I would use. And then he told me that the tools he's using are so incredibly good that refactoring for them is suddenly so much simpler. So I don't want to advertise any particular tool now, but I kind of can believe that. If the tool is really focused on code development, prepared for that, I would really try. And that should definitely simplify this evolution of code, this update of code. It should not put you into a lot of danger.
And that's for if you are an application developer. I see two kind of people out there. There's application developer and then there's library developer. So let's just get into the shoes of the cute company now. They have this rat nest of pointers and they want to modernize and they're doing a lot of things and so on. But don't you have a problem that you have all these clients out there, billions of users, I'm sure they'll say, that are using all that? You cannot refactor into their code bases.
Because it's a published API. API. So people use that already. You just cannot change it. The only way to change that is to just release a new version. Of course, if you now radically change everything, people are not happy either because they would have to change all of their code. So you probably also have to think about a slow transition. Perhaps introducing a wrapper API, something that enables you to modernize things by encapsulating pointers. So instead of giving a pointer, you give them something that's a little more value-like, perhaps. But no. You cannot just change everything and then hope that people adapt. They will not. Will just not use the new version.
Klaus just mentioned in DC Tech Town, and that's where we are right now. I actually spent the last 2 days in Klaus' workshop, which kind of ruined my next question. So let's assume I didn't, or at least let's assume that this is prior to his workshop. So up until that workshop, I have multiple times tried. I've watched several presentations you did online with type Erasure. I've typed them in, followed along, nodded, said, now I understand it. And a month later, I got back and said, okay, what is the trick? How do you get started with this new way of working with things? Any suggestions on that?
So first of all, for those who don't know, type Erasure is one of the ways that we use to encapsulate pointers. Pretty much is a wrapper around a pointer, a polymorphic pointer, and this type Erasure wrapper pretends it's a value. We can copy this, we can move that. It feels like a value. So how do you start with this? Well, definitely you not just advertise my workshop. Thank you very much.
Wow, it was a good workshop.
That definitely is a good way. So if somebody shows that to you and then gives you the opportunity to try this yourself, that of course helps. But not everybody can attend my workshop. I mean, I would be happy, definitely, but not everybody can do that or afford that, cannot travel to Europe, whatever. So what I've done is I have spent an entire chapter in my book trying to explain that step by step. If you then follow along, if you read along, you should realize it's not a lot more than you would write anyway. It's an encapsulated inheritance hierarchy in the simplest form with a template constructor, and it's almost it. The talks I've done also were supposed to help a little bit. If you now say that this didn't create this click for you, okay, then I have to improve my talks in the future.
And this is where I usually do like this, and then it's like that, and I could never figure out where. In the show notes, I know they are below me, put in a reference to one of Klaus's talks from like CPPCon, pretty good one on type Erasure. You even talked about how to improve speed by placement new in there. So it's like, I need to put these down though. For me.
It has been 2 talks. The first one is about why is this better from a design perspective? Why does this help with separating concerns and the decoupling? And the second was about implementation details. It just was an hour. This is a topic that you can't really spend many hours on. But I tried to show the simple implementation and optimized ones. For instance, the small buffer optimization and manually implemented virtual functions, which take away one indirection.
Which, on its own, for any geek, I mean, it was mind-boggling for me to see that you could. Well, I'm not gonna do spoiler alert here. It was a pretty interesting talk. A bit later today, my timeline, mind you, I'll be talking to Jason Turner. I'm sure you know that guy. He's the guy that is like two-dimensional brick guy. I wonder if there's a three-dimension to him. He is a C++ weekly guy, and he is diving into every little detail of C++. I will ask him to argue why it's more important to do that than to get into the cloudy version that you do. So I will offer you to argue why it's more important to look at the design overall than to know all the tiny little details.
So my argument is that if you get your architecture and your design right, then you will have a much, much easier life later. So from my perspective, architecture and design is the most important thing about a software project. If you would change something later, changing little details, that's usually simple because it usually affects only a few people, perhaps even just a single person. But changing the architecture affects everyone. And so it's so much harder, so much more difficult to change that. And so this is why you have to get this right first. You might not get it right first, but you might get close, and then hopefully changing things a little bit may affect many people, but it might not be so bad. Then second, I'm the one who says, keep your code simple. As simple as possible. You do not have to go into every single detail. So as soon as it's simple, people have less problems understanding it, changing it. And so it's probably also, there are less bugs, fewer bugs. Good. So this is why I feel it's not necessary to know about every tiny detail, about every trick, etc. But still, I understand the fascination behind this because it's interesting to see how you can use a feature for things that it actually was intended to achieve. Variant template parameters, for instance, the many tricks that you have to then still iterate over all the values in the pack, the many different ways you can actually do things that were never intended to be done. It's fascinating, but not strictly necessary for every code base.
Yeah. So I might say exactly the opposite when I'm sitting here with Jason, but now I will say at least you should spend your quality time reading his book, thinking very hard, and then on the train you can watch Jason's YouTube.
And then I'll get in the show notes and in the comments. Yes,
Klaus, it was a pleasure talking to you.
Thank you very much.